Hi, I am Chandrasekhar Gupta and we are discussing programming concepts. We have seen linked list previously and now it's the time to look into stacks. Before going into stacks, I want every one of you to look at a familiar thing which is an array. Rotate it by 90 degrees. Now this is a stack. Do you remember anything by looking at this figure? This figure which is right here, make it circular and imagine it in 3D. Doesn't it represent like a well? Yes. So we have a well here, and what generally you do in wells? It will be having water, and with the help of a bucket you will try to fetch the water from the well, and whatever is on the topmost layer or whatever is on the top of the well, that water will be replaced in the bucket. Similarly, take this stack. You will be having a top pointer which is similar to the bucket in this case. As you have taken the water which is at the top layer, you will try to take the data which is at the topmost box with the help of this top pointer. Seems familiar? That's how stacks work. So after understanding stacks and how we are able to extract only the topmost part of the data, you know applications like Paint and web browsers use stacks to process or store information. How that is done? Let's have a look.
Suppose if we are in Paint application and if you just try to write this text, we have undo and redo operations in Paint. Undo and redo. Whenever you have written this text, the sequence of operations that you have performed in this application will be pushed onto a stack. So if you have first written R will be pushed and A and M respectively. When you press this undo button, the last operation that has been performed was writing of M. So whatever is present on the top of the stack, that operation will be moved to another stack. It will not be on this stack and on the screen anymore. And if you press undo one more time, then A will also be removed from this stack and it will be moved to the other stack. So it will be disappearing from the stack and from the screen as well. Now you are having only R in the screen. If you press redo, then whatever is present in the other stack will be again pushed onto the old stack and it will appear on the screen. So RA will be on the screen, and if you press redo again, M will also appear on the screen. If you just observe, I have replicated undo and redo operations with the help of a stack. Let's say this is undo stack and this is redo stack. Whenever undo happens, the last operation will be shifted from this stack to this stack, and whenever redo happens, the operation on this will be shifted from this to this and it will be changed on the screen. That is the practical application of stacks.
Now we have seen a lot about stacks. I want every one of you to leave it further and just think you are a game developer. You are hired by some company and you want to develop a game for kids. They want to learn numbers. So from your part, you need to develop a game which pronounces things in reverse. Let's say numbers from 1 to 10. It has to be pronounced as 10, 9, 8 and so on. What do you think is the practical approach to work on this, or what is the best suited data structure in this analogy? What are you waiting for? We have already discussed stacks and we can use stacks to do so. Let's have a look.
To design this number game, let me take all the numbers from 1 to 10. Now I have to replay the numbers in reverse fashion, 10, 9, 8 and so on 1, so that they can learn the numbers in an effective manner. Data structure you can probably use for this operation if you think this is the data structure that we have been dealing with. Let's take a stack and let's push the numbers inside it till 10, and whenever the number has to be told or whenever the number has to be represented, just try to pop. That means that remove from the top of the stack and give it as output. If you have observed carefully, if this is a stack, we are having two operations. First one is push, where you tend to put some number on the stack, and second one is pop, where you try to remove the top element from the stack. Let's try to see how this push and pop operations are implemented with this stack. For implementing a stack, if you observe carefully, we can take an array and if you rotate it by 90 degrees, let's say, we can make it a stack, or as we have discussed, we can even use a linked list. Let's stick with array for now and let's try to look after this push and pop operations. For defining push operation, let's see what exactly is happening here. Now I have a stack which is an array that has been rotated by 90 degrees, and I want to have a number. This I have to push it inside, so I have to place this value. If I have one more number, I have to place on the top of it. So I need to have an index which is pointing to the top. Let me call it top pointer. As initially nothing is present on the stack, let me initialize top to -1. As we know that array indexing starts with 0, I am pointing the top to -1. So initially the top is pointing to -1, and let me declare an array which is a stack. So this is a stack array. Let me call the size to be 10. Now after declaring the stack, we have to push the element inside it. For that we need to have an element. Let's say it is at integer k and it has to be pushed onto the stack. We have this value, so I have to push 1. This is a function call, and let me see how this function call will be implemented. What it has to do, it has to take this number as input. So I am defining a function. I am calling it void because I don't even know what is the return type as of now, and I am naming it to be push. I need to take one input of an integer. So integer, let's say a, I am taking as input. Now the a is having the value 1. It has to be placed onto the top of the stack. This can be accessed with a of 0. As I am using top as an index which is -1, I can increment the top, right? I can increment the top and then I can actually store the value. Let me do that. So I am incrementing the top. Top is equal to top plus 1. This makes top to be 0 in this case, and I am putting array of top as a. Let me see if this works. I have called push of 1. So in a I have taken 1. Okay, I have incremented the top. Top is now 0, so which is pointing to the first location. Array of top is 0. That translates to a of 0 is a, which is 1 in this case. So 1 will be pushed onto the stack. Now if I want to push one more, let's say if I want to push 2, let me see how it behaves. Now a will be having 2 and top is equal to top plus 1. As top is 0, now it becomes 1. So top points here, and it translates to a of 1 being a, which is 2 in this case. So 2 will be pushed. Perfect. So this push function is working perfectly for me. Similarly, let's try to decode the pop function. Before interpreting pop function, let's carefully examine what happens there. If 1, 2 is on the stack, when I call pop, I am not passing any argument, okay? And when I call pop, whatever is present on the top of the stack, it should come out of the stack, and this should be disappearing from the stack. How can I do that? I am having the index which is top. So this element is nothing but array of top, right? By writing this, I can actually have this element, and I need to disappear this element from the stack. That means that if I just reduce top by -1, I'll move to the previous location and this will be erased from the stack. That will be present on the stack, but it can be overwritten in the next time. But reducing it by 1 does the job for us. Now let's try to define this pop function. As I can expect, it has to return me the value at that position, which is an integer. So the return type is an integer. It is an integer, and I am trying to define the pop function, and it is not taking any arguments, so I am not having any functional arguments. Now I have to return the element which is at this position. Let me take an integer k and let me transfer, if this stack name is a, let me transfer whatever is on the top of the stack to this integer. Now k is actually, if stack is having 1 and 2, k is actually having the value of 2, and I have to reduce the index of the top. Top is equal to top minus 1. I have to return it also, right? So I'll be writing a return statement, return k. This actually works perfectly for pop function. If you want, you try to take an example and try to decode it.
Now, by understanding all about stacks, we have to look into the next data structures, which is queues. So what are the practical application of queues? Just say you are at a call center and you need to monitor the entire process. So you keep on getting the calls and you have limited resources. Let's say you are having 5 people, you got 10 calls. What is the data structure that you can use, or how you can store the data so that it can be processed accordingly? Think about it. Stay tuned to find out.